Good day everybody, we have a lovely question. Foremost, let me draw the triangle. Okay, so this is A, B, C. We need to get A, B. This is right triangle. Now, the following informations have been given. So, points A, D, E, and B are consecutive points. So you have D here and then you have E here, so probably I'll place D here. Okay, this point is D and this point is E. There is a hit from D to E, and or I would say from D to C and E to C. Now these are all of equal parts. The division is equal. Now AD is equal to DE is equal to EB. Now if theta exists such that this is theta, such that CD is 5 cos theta and CE is 5 sine theta, we have to find AB. Okay, so let us do that. Now what I wish to do is, foremost I would like to make the following observations. Now you have to represent AD in terms of AB and also AE in terms of AB. Okay, so these representations are very crucial. So I'm going to pause the video. You can pause the video and work this question. When we come back, let's see how the correct answer is obtained. Okay, from the figure, so what do we see if I were to consider AE? This is the distance or the length of AE. AE is clearly 2 over 3 times AB. Also, if I were to take this as D, DE is 1/3 the distance of AB. Okay, now having got that, I would be utilizing the Apollonius theorem. So what is Apollonius theorem? Let me draw the triangle here. This is the Apollonius theorem. Now imagine CXY is a triangle given to us, and say M is the midpoint of XY. Then we have Cx squared positive Cy squared is equal to 2 times of Cm squared positive Xm squared. This is the Apollonius theorem statement. Okay, now this is O actually. Let me rewrite that. Apollonius, Apollonius theorem. Right? So this is the rule which we are going to be applying So for that, what I would do is, foremost I would consider triangle, say ACE. So let me draw ACE. Okay, this is A. Probably I'll take this as A and this as C. Okay, C being the top point, and this is E, and this point is D. Okay, so this is going to be CD. So this is how we have this system being in place. Okay, so this is going to be AC squared by Apollonius theorem. We have, what do we have? AC squared plus CE. This is CE squared is equal to 2 times of CD squared plus DE squared. But DE is 1/3 of AB. So this is going to be 2 times CD squared. What is CD? CD squared is 5 times cos theta. So 25 cos squared theta positive. DE squared is square of this. This is going to be 1/9 AB squared. So this is AC. What is AC? Do we have anything for AC? No, we don't have anything for AC. So AC squared positive CE squared is 5 times, that's 25 times sine squared theta. Okay, so this is what we have got. We can distribute this. We get 50 cos squared theta positive 2/9 AB squared is equal to AC squared positive 25 sine squared theta. This is system 1. Now what I wish to do is, I will have to consider the next part. So now I'm going to consider this is C, D, B and E. I'm considering this region. Okay, so by Apollonius theorem, we have, so what do we have? We have CD squared plus CB squared is 2 times of CE squared plus DE squared. Now CD squared is 5, right? So I'm going to write this as 25 cos squared theta. I'm going to write this as BC squared, right? I can. So this is 25 cos squared theta positive BC squared is equal to 2 times of CE 5 sine theta 25 sine squared theta plus DE is this 1/3, that's 1/9 AB squared. So this is 50 sine squared theta positive 2/9 AB squared is equal to BC squared positive 25 cos squared theta. This is 2. I'm going to be adding 1 and 2. We get, so what is 1? AC squared, let me write that, AC squared plus 25 sine squared theta is equal to 5 times cos squared theta plus 2/9 AB squared. This is 1. So you add these two together, what do you get? You get AC squared plus BC squared 25 is common. You take it out, you get cos square theta plus sine square theta. You can add these. So this is equal to, you add these things, you get 50 sine square theta positive cos square theta. You add these, you get 2 over 9 AB squared, right? So you have a AB squared and AB squared. So this is 1, this is 1. So you have AC squared positive BC squared. 25 is, you bring this is 1, so you bring 50, and you have on the side 2 over 9. 2 times of AB squared. So this is going to be a negative, right? Negative 25. So I don't want a negative 25. I push it to the other side. Now AC squared plus BC squared. So watch out. AC squared plus BC squared. This is right triangle. So by Pythagoras, this is going to be what? This is going to be AB squared. So AB squared, you bring this down, you get 4 over 9 AB squared is equal to, on the side you have 25, because it's a negative, it goes the other side, it becomes positive. So I take AB squared out, I get 1 negative 4 over 9 is equal to 25. This is going to give me 5. 5 over 9 is equal to 25, right? So AB squared is equal to, 25 times 9 divided by 5. 5 divides here, 5 times 9 is 45. This is AB squared, but I want AB. So AB is equal to root of 45, which is nothing but square root of 9 times 5. So I'm going to write it down here. So AB is equal to root of 9 times the root of 5. Root of 9 is 3 times the root of 5 units. So this is my AB. It's a lovely question. Okay. So AB is 3 times root of 5. Isn't it? Thank you everybody. Please like, share and subscribe.